Hi everybody, so welcome to this next video, which is on chapter 6, and I'm going to be looking at the examples that go with exercise 6b, 6c and 6d. So these are the inverse trig functions, i.e. cosec, sec and cot, but they're relatively straightforward to put in the calculator as long as you remember that cosec is 1 over sine, sec is 1 over cos and cot is 1 over tan. So in example 4, you're asked to sketch the graph of y equals 4 cosec x in the interval minus pi to pi. So you'll see here, so 4 cosec x, so I've had to write that as 4 divided by sine x. And again, if in doubt, put brackets in it. So I've done that there. So if I draw that and then go V window trig, it doesn't look good, right? You can't see anything. And the reason is because of this 4 has stretched it outwards. And this is only going up to, what's it going up to? So it's only going up to minus 1.6 and 1.6. So I'm going to make that minus 10 and 10. And I'm also going to correct the domain as well, so the x value. So I'm going to do that between minus pi and positive pi. And then we should hopefully get the same result. Oops, I was going to put it delete. So shift. There we go. Didn't press shift. So, let's have a look at that. What it looks like now. So it looks good now. Yeah. So we've got these like 2 bumps here, which corresponds with this one and this one down here. Okay. It also wants us to sketch the line y equals x. So if we do that, so y equals x, and we should see that these do not intersect. You could confirm that by going G solve intersect, and it won't find anything. Okay, so that just confirms what this has done down here. All right. So the number of solutions for the equation 4 cosec x minus x, i.e. 4 cosec x equals x, in this particular interval would be 0. So next question. So let's delete these and get ready for the next one. So for part example 5, so just scroll down to it. Oh, far too far. Oh. Where are we? Sorry, example 4, isn't it? My mistake. So example 4. No, sorry, it is example 4. Why have I not done example 3 then? Okay, so I've missed example 3. Never mind, I've done it in the wrong order. So sketch the interval minus 180 to 180, the graph of sec theta. Okay, so sec is this bit here, and this bit here. So for this one, I will go through it because it could be useful. So sec is 1 over cos, so 1 divided by cos of x. But this one, obviously, we're in degrees, so we're going to need to go shift menu and go back to degrees. That's good. I'm going to draw it, doesn't look good. V window, trig, and we want it in interval minus 180 to 180. So minus 180, execute, 180, execute. Hopefully, it'll look like this one, which it does, yeah? So here's our bump here, which corresponds to this one, and here, and here. If I wanted to get a bit more of it, I could go V window and then just adjust my y values maybe to between minus 5 and 5, something like that. And then we should get a bit more of the curve there, which we do. Okay. Important for me to say at this point as well is it doesn't show you the asymptotes, the dotted lines. So if you were to sketch this yourself on paper, you then need to do a dotted line that goes down here through minus 90 and through here at positive 90 as well. Okay. So that's the example, example 3. So I've done them all the way around, so sorry about that. So example 5, so the last one, and again, we can see what this looks like here. So the calculator is just going to confirm what we want. This one's in degrees, but it wants it between 0 and 360. So I'll have to consider that as well. So 1 plus sec 2 theta. So 1 plus sec is 1 over cos. So 1 divided by bracket cos 2x. Okay. Now it might be that we need to put another bracket here and here, but we'll see how we get on. So let's execute that and draw it. Looks pretty good. So V window, and we just want to adjust it between 0 and 360. So 0, execute, 360, execute, exit, draw, and there we have it. Why has that got too many? Oh, that's fine. Yeah, so the one we want is down here. So it sketched it for, this is normal sec here. So obviously if you do sec 2 theta, that's going to squash it. Yeah, so it's going to repeat. So you're going to get this bit here, which goes to this bit, the upside down loop here, the second one here, which go to these two. All right. So the point is, if you put this in right, you can be pretty sure you're going to be safe. And again, there's no asymptotes drawn, so you'd have to draw them here, and here, and here, using a ruler obviously, and here like this. Okay, so it won't do that for you, but you can see that there should be one there because there's nothing there for the graph, so that implies that there's an asymptote. And you know there's going to be asymptotes there anyway because it says that you know that there are asymptotes on the inverse trig graphs. All right. So that's that goes with exercise 6b. I'll keep going and I'll do exercise 6c as well in the same video. So it's just one example. I think I was going to do on this one. So example 8 was the one I was going to look at, which is starting to solve equations, which again, relatively straightforward to do as long as you key it incorrectly. So for example 8, we've got two parts to this. So our first part is sec theta equals minus 2.5. So again, sec is 1 divided by cos x. The way I always remember, by the way, is the third letter. Yeah, so the third letter of sec is c, so that's cos. The third letter of cot is t, so that's tan. The third letter of cosec is s, so that's sine. All right. So let's execute that, and then we're going to do minus 2.5. And that looks good. That looks immediately good, yeah, because I've already got the range correct from my previous example. So we should get, when we solve this, solutions of 113.6 and 246.4. So let's just check that we get those. So G solve intersect. So 113.6, that looks good. And 246.4, that looks good as well. Fantastic. So cot 2 theta equals 0.6 is our next one. So cot 2 theta, so that is, so cot is 1 over tan. We're going to go 1 over tan 2x, and that equals 0.6. Obviously, your method to solve this would be different. This is just checking that you've got it right. Draw it, looks pretty good. Haven't done a sketch of this one actually, interestingly, but so we're just looking to get these answers here. So 29.5, 120, 210, and 300. So we have got 4 solutions here. Look, 1, 2, 3, 4. So let's just check they're the right ones. So 29.5, yes. 120, 119.5, yeah, but it's rounded it to 120, that's fine. 209.5, rounded to 210, and 299.5, rounded to 300. So that one looks good as well. So next example, so moving on. So we've done 3, 4, and 5 here, not in the right order, apologies. We've done number 8, so we're just going to do number 12 now, and then we'll go on to the next video. So example 12. So this is this quite complicated quadratic equation with 4 cosec squared theta minus 9 equals cot theta. And again, it's in the interval 0 to 360, so I shouldn't need to fiddle around with my V window, which is good. So this is a tricky one to put in, right? And again, as I say, if in doubt, put more brackets in. So we're going to go 4 cosec. So we have to go 4 bracket. Cosec is 1 over sine. So 1 over sine x. And we want to square that as well. So because we're going to square that and we're not squaring the 4, I'm just going to put another bracket in here to make sure that I've covered that. Yeah, so 4 cosec squared. It's really clunky, isn't it? Right. Hopefully they'll be updating these calculators at some point. And then minus 9. And then we're looking for cot theta. So that's 1 divided by tan x. All right, so let's see what happens when we do this. So in the book, they get 4 solutions. So they get 38.7, 210, 135, and 315. So we have got 4 solutions here, so that looks good. So let's G-solve and check that they're right. So G-solve intersect, 38.7, that's good. 135, excellent. 218.7. Oh, that's gone funny, hasn't it? That's weird. And then 350. Now, I suspect that this is a mistake. Well, I'm going to go with it. This has to be a mistake in the book here. Yeah, because if you had 100, if you had 38.7 to 180, you do not get 210. So that is a mistake. So that should be 100, and that should be 219 to 3 significant figures. All right. So I'm confident enough that the other 3 are correct. So that one must be wrong. And what we've done on the calculator is right. Okay. So I'll just go back and show you again what that one looked like. All right. So 4 cosec squared. So cosec squared, basically, you want to do cosec, which is 1 over sine, and then square it. So because I've got this 4 as well, maybe, in fact, maybe I'll just go and delete these and see what happens. So how about if I delete this first bracket? Does that cause chaos or not? I suspect it will be okay. No, we're okay actually. All right, but like I say, if in doubt, add that bracket in and you should be good. So very nearly at the end of these videos now. They're quite short, hopefully, and they will be useful, I really think. And so I'll see you in the last one, which will be going with chapter 7, and it's just the exercise 6D in that particular chapter. Right, cheers folks, see you in a bit.